So this is the little AC panel meter that I installed on my variable isolated power supply. So I picked up another one of these because I wanted to take a look inside and see what makes it tick. So let's do that. Okay, so this is what you get in the box. You get the meter here. This is their little current transformer. This is the AC power meter. And then here's the instructions. Had a couple of people ask, are the instructions readable? And I guess you got one page of English and one page of Chinese instructions, but it's reasonably good. It covers the basic operation. So if we look at the unit here, again, this is the PZEM-061, and it appears that the Peace Fair is the manufacturer. This one has 0 to 100 amps, AC 80 to 260 volts. It seems to work down to about 60 volts on the low end, so it's a little bit better than that range. Yeah, so here's the AC current transformer. So this is what senses your load current, and it's about a 16 millimeter or 5/8 inch diameter inside the current transformer, so it would fit around a pretty large size cable, and apparently it's rated at 1000 to 1, so for every 10 amps of current flowing through the middle of the transformer, you get 10 milliamps of current in the two wires. And there are apparently some 1000 to 1 split core transformers that you could probably use with this in place of this, because for instance, if you wanted to install this current transformer in your main breaker panel outside your house, you would have to disconnect the wire and then run it through the middle, unlike one of the split transformers where you can open up the core and then clamp it over a wire. There's also this open source project called the Open Power Meter project, and they seem to use a 2000 to 1 current transformer, so you have to be careful. It seems like there's a lot of those open power monitor transformers available, but they put out half the current of this one, and I'll mention that a little bit later. Here you get the same wiring diagram. Your load goes through the current transformer. Those two wires come in the side here, the top two connections, and then the bottom two are your AC voltage. This comes off, so the cover snaps off, and then there's 4 little screws that hold the circuit board in place. And if we pop that out, just to show you, there's nothing on the back side. You just have your push button and the liquid crystal display. Here's your power terminals. There's a 1 microfarad 275 volts. This is your power supply essentially. It's a capacitive dropper, and underneath this capacitor there's a bridge rectifier and a little 5-volt regulator for the rest of the digital circuits. And then you can see here this large resistor right there. That is what senses the current in here, and it's about a 100 ohm resistor. You've got these two wires hooked up across that resistor, and since this was 1000 to 1, so if you have 100 amps flowing through this CT, you're going to have 100 milliamps flowing through these two wires. You shorted them, or if you put those across that resistor, 100 ohms with 100 milliamps is 10 volts, so you're going to get 10 volts full scale across that resistor. If you wanted to change this to work with a different transformer, say you had a 2000 to 1 transformer, you could change that resistor out, put a 200 ohm resistor, and get the same 10 volt reading with a 50 milliamp input. So let's take a look here at the chips. There's basically 3 large ICs on here. This is a Renergy or Sunshine Science RN8208G, which is a single phase metering IC. So this takes the voltage waveform and the current waveform and does the power factor calculations and produces the instantaneous voltage, current, and power. And then this is a 3.579 megahertz clock, which forms a real-time clock, because this thing needs to know about seconds and minutes and hours, because it needs to compute kilowatt hours or watt hours. And I'll put links to all of the chips in the video description. And then this is the brains of the unit. This is an ST Micro 32F030. So it's an 8 megahertz microcontroller. That's the crystal for it. Here's your ST-Link 5 pins, I guess. This is the other chip. This is a Holtec HT1621. It's a RAM mapping 32x4 LCD controller. So that's pretty much the inside of the device, just the 3 ICs, and like I said, there's your power supply AC side over here. So anyway, that's my inside look on one of these. They're pretty good build quality, and there's a bunch of interesting variations on this, and also have had a few viewers pass on some interesting part numbers and information, like on the winding ratio of this current transformer. And I'll try to get a hold of a couple of those other variations on this, and we'll take a look at those. And as always, thanks for watching.